Hey guys, today we're going to talk about one of my favorite things, grids. And I'm going to tell you in this video why I really like grids, and it has to do with me moving to Amarillo. Anyway, before I do that, in geometry we call this the coordinate plane, and you know that a grid is just a series of horizontal and perpendicular lines uh, uniformly spaced out through here. And in geometry, we label points on these lines and call them coordinates. So, when we talk about this, our grid, our coordinate plane, is divided by this xy axis here. This is y is vertical and the x is horizontal, and you probably remember this from algebra. This is the first quadrant. It is positive x's and positive y's. When you go move to the second quadrant, it is negative x's and positive y's. In the third quadrant, you have negative x values and negative y values. And in the fourth quadrant, you have positive x values and negative y values. So I want you to put this right now in your whisk, and I want to move over here to our book and show you that today we're going to use this coordinate plane to find the distance between 2 points and also find the coordinates of a midpoint of a segment. So if we move back, the first objective we're going to talk about is using the distance formula to find the distance between 2 points. So I've put this coordinate plane up here, this grid, and I've marked point A and point B for you. Point A is negative 4, 2, right here, and there it is on the coordinate plane. And point B is located at 6, 5. Now this distance formula looks really fancy, and it's actually related to something that you probably learned, I think you did in Algebra 2, which is the Pythagorean theorem. And if you take a look at it, I want to show you that if I drew a horizontal line across here to where the value of straight up and down from where B is, and I drew a line up and then back down across diagonal, I have a right triangle. And the distance between A and B, it's not a horizontal line, is it? It's not a vertical line, it's diagonal right here. Now, if it were horizontal or it were vertical, I could use our formula that we learned back in chapter 4, not chapter 4, chapter 1, lesson 4, when we had to use this formula right here called the Euler postulate. I took the 2 points and I subtracted them and took the absolute value. You can do that if you have horizontal or vertical points. But if you do not, I'm going to move back to our lesson now so I don't get messed up. If you do not have horizontal or vertical segments, you need to use the distance formula, which is actually the Pythagorean theorem. You're going to take the values of x, subtract them, square them, and add them to the values of y subtracted and squared. So, for instance, 6, take away negative 4, there's your 2 x values. You're going to subtract those and square them, and when you work that out, it comes to 100. Then your y's, 5, take away 2, subtract those and then square them, so 3 squared is 9. Add those together, you have 109, and when you take the square root, the distance between those 2 points is 10.44. And if you worked it out the Pythagorean theorem way, if you counted the distance between A, which is negative 4, And over here, this line is 6, and negative 4 take away 6 is negative 10. Absolute value of negative 10 is 10. And if we squared that and we added it to, I'm going to start right here. 2, 1, 2, 3. 3 squared, which is 9. Look at that. Look at how that's working out. This line squared plus this line squared is supposed to equal this line squared. And so that's how this distance formula came about. Very smart man a long time ago. So some of you might be wondering, well, how do you know which one is x2 and how do you know which one is x1? It really doesn't matter. So down here I actually switched my x's around to show you, what if I switch my x's and y's around? Will I get the same distance? So this time, let me show you both of them. Instead of 6 take away negative 4, I did negative 4 take away 6. And instead of 5 take away 2, I did 2 take away 5. And when I worked it all out, I have the same distance. So it does not matter which x you put first, you will still get the same as long as you pair the x's together and you pair the y's together. So that's the distance formula, finding the distance between 2 points that are not a horizontal or a vertical line. So if we move over to the book, I want you to use the distance formula on this problem. 1A, don't worry about 1B, we just talked about it actually. So do 1A, pause the video, and see if you can come up with the distance between those 2 points. Alright, hopefully you paused it and you found that the distance between those 2 points was 8.6. Alright, we're going to move on. And we're going to talk about next finding the midpoint. Alright, so let's pretend here we have this line segment and its coordinates are -1, -2. And over here the coordinates are 7, 4. Well, when you find the midpoint, you're finding the point right smack dab in the middle. And if you think about that, when you find a number in the middle of 2 different numbers, you're really finding the average, right? The mean, another way to say it. And we know from a long time ago in math that you add the 2 numbers up, you divide it by 2, and that should give you the mean, the average, what's smack dab in the middle. And that's exactly what we're going to do. This right here is just a fancy way of saying that's what we're doing. We're taking our 2x values, adding them up, and dividing them by 2. Same with the y. So if you take a look, we've got 7 and -1 as our x values. I've added them up right here for you. 7 and -1 is 6. I'm dividing them by 2, and I get 3. So that's my x value. What about y? Well, 4 and -2. So I'm going to add those together, which is 2, and I have to divide it by 2 to find the mean, the midpoint, the average. And 2 divided by 2 is 1. So my y coordinate is 1. So the coordinate of the midpoint is 3, 1. So if I move over to our book, I need to go to my second objective, which is finding midpoints. I'm going to pull up an example, and I want you to take these 2 points, 2, -5, and 6, 13, pause the video and find the midpoint. Alright, hopefully you did that and you worked it out and you found that the midpoint happens to be 4, 4. If you did your algebra correctly. Alright, the last thing we're going to do is find an endpoint. So let's move back over here because this is what you should be writing in your whisk. If I scroll down, what if I'm given a midpoint and one endpoint, and I'm asked to find the other one. Well, I'm going to use what I know to find, the formula I know that I use to find the midpoint, and just kind of go backwards. So let's work with our x's first. If I know that 2 is the midpoint of my x coordinates, I'm going to plug that into my midpoint formula and find my missing other endpoint. So 2 is actually equal to this -6 plus whatever my other endpoint x value is. So I just put x divided by 2. And I used my algebra skills, multiplied both sides by 2 to get rid of my fraction, then added 6 to both sides, and I found that the midpoint of my x coordinate is 10. Not the midpoint, I'm sorry, the end point. Sorry about that. End point. Now I'm going to do my y. I'm going to do the same thing. The midpoint of my y value is 2. So 2 has to be equal to this y, 6, plus whatever that other y was, or is, divided by 2. So I plug that into my algebra problem. I'm going to multiply both sides by 2 to get rid of my fraction. And then I'm going to add a -6 to both sides to get my variable on one side by itself. And that gives my y value of that endpoint as -2. So I just kind of went backwards with what I knew about the midpoint formula to find the endpoint, which, I didn't mean to do that. Sorry about that. To find my endpoint, which is 10, -2. So knowing that, let's move over here and see if you can work this problem out. So you know the midpoint is 4, -6, and one of the endpoints is 2, -3. What is the other endpoint? So pause the video and work this one out and see if you can find it. Alright, hopefully you did that and you discovered that the other endpoint was 6, -9. If not, look at your algebra one more time. Alright, if we go back over, I'll show you why I really like grids at the end of this lesson. So I brought up a map of Amarillo. This is Amarillo. Did you know that Amarillo was mapped out into a grid system? That's how they designed the city. Look at how it's just in the blocks. I'm not very good with directions, and so when we moved here, my husband was like, "Oh, you're going to get around so easily because everything's in a grid. The streets go horizontal or vertical. You're not going to get lost." So I put in a map of Atlanta, which we lived close to and we went to quite a bit. It is not in a grid system, and that place is crazy. Don't drive in Atlanta because it is so hard to get around. I'm going to show you this picture down here. Where'd it go? I lost my picture. That's not where it's supposed to be. Oh my goodness. I'm so sorry. I don't know how my picture ended up way over there, and now I can't find it. Anyway, it's a picture of Spaghetti Junction in Atlanta. And if you Google that, you'll see that Atlanta was not designed in a grid system, and nobody in their right mind should drive in that city. So, hope you enjoyed your lesson. We'll be talking about this and working out finding the distance of a segment. We'll be finding the midpoints and the endpoints very soon. Thank you very much.